everyone, welcome back to our channel AI World for You. In today's video, let us discuss about the various properties of task environments in the agent's point of view. How the agent is able to develop the knowledge and how is it able to execute the actions just like a human. So let us see what are the different environments which are in the observation of our agent. Coming to the first one, which is fully observable versus partially observable. So considering a fully observable versus partially observable setup, right from the name we can understand that the agent is able to completely observe its environment, that is completely observe its surrounding. Whereas in a partially observable environment, the agent cannot observe the entire environment at once. Like for example, in the vacuum cleaner robo example which we considered earlier, there were two rooms, A and B, right? So in that case, the vacuum cleaner is present in room A. Let me show you. See, the vacuum cleaner is present in room A, and here only the environment of that particular room, that is A room, is visible to the vacuum cleaner at that point of time. But the task given to the vacuum cleaner agent is to clean both the rooms. So this can be an example of partially observable environment. But suppose the vacuum cleaner was in one room and its task is to clean that room alone, then you can consider it as a fully observable environment, right? So here, fully observable, it says that the complete state of the environment is known to the agent through the sensors at each point in time, not at a later point in time. Consider partially observable. The agent can access incomplete or noisy information. That means it will not get the complete information about the environment. So some of the examples which we can consider for fully observable environments are a simple game of chess or checkers, and for partially observable environments we can consider driving a car in traffic, because when the car is being driven in a heavy traffic area, only the visibility is limited, right? Not the entire stretch of the road is visible for our car. So the visibility becomes limited and the car is able to view only its front view, back and left and right view. It cannot see beyond. So that can be considered as a partially observable environment. Moving on to the next one, which is single agent versus multi-agent type. So here if we observe single agent, as the word says, it means only one agent, only one agent is going to operate at any given point of time, and it will operate independently. Coming to multi-agent, we have more than one. So here when there is more than one agent involved in doing a specific task, those two agents can fight with each other, or they can also go along with each other and cooperate. So that is why we define something called cooperative or competitive. So the examples which we can consider for single agent is solving a crossword puzzle. And for multi-agent, if you see, taxi driving, because there will be other drivers who are trying to overtake this and they may also try to race with the self-driving car. Also you can consider some multiplayer games where more than one agent, more than one player is involved. So multiplayer games where each player will compete with the other to win the game. So that kind of a multi-agent atmosphere is a competitive one. Whereas suppose that you have certain situations where we have to go and rescue a particular area. We have to rescue the humans in an area. There all of us will collectively work to help the humans, right? That is a cooperative type of environment where the agents will work cooperatively. Moving on to the next one, we have deterministic and stochastic. So deterministic, the term, it indicates that the next state of the environment is completely determined by the current state. That is, the agent will have a clear-cut idea of how the next state is going to be. That is determining something. Determine means to find the solution of something, right? So it is deterministic in nature, means it has a clear-cut idea of what it is going to do next. The next state is well determined by the agent. And coming to the stochastic environment, there exists some kind of randomness. What do you mean by random? We are not very particular or very clear about what is going to happen next. So the next state has some element of vagueness or some amount of clarity missing, and that is due to noisy or incomplete information. Okay. So that is about deterministic and stochastic. Coming to the next one, which is static and dynamic. As the name suggests, static means the environment is going to remain unchanged. Static environment is where the agent will be exposed to the environment, which is going to remain the same throughout. The agent can reach the goal in that environment itself. But whereas in a dynamic environment, the environment keeps changing and the agent's decision-making process also must reflect the changes. So let's consider the example of a crossword puzzle. There, the crossword puzzle is fixed and we have to think and solve the puzzle. Whereas in a dynamic situation like taxi driving, the traffic may vary, the route may vary. So there may be some take diversions board, and you may have to be diverted from your original route. So these kind of things exist in a dynamic scenario where the environment is also going to keep on changing. So there the agent also needs to change, right? So that is about static and dynamic environments. Coming to the next one, which is episodic and sequential. So episode itself means that one by one, that is the agent's experience is divided into discrete episodes. That means each step one by one. So here the decisions will be based on the current episode only. That is, the decisions made in one episode do not affect the next. Coming to sequential, each decision is going to be sequential, one after the other. So previous step what I do will affect my next step. That is sequential. So whatever decision we take now, it will affect our future outcomes. That is sequential. Episode means one episode is totally independent of the other. So in an episodic atmosphere or an environment, there the one particular step is not going to affect the other. But in a sequential scenario, it means sequence itself means what? One after another. So one particular step will affect the next step. Okay. Let us take the example of a quality inspection on an assembly line. The quality in one particular component is not going to affect the quality in another one. Consider the taxi driving example. Suppose I go and collide with my vehicle. The next sequence is going to be disturbed. I am unable to reach my destination on time, right? It's going to affect my next step. And consider some environments like video games where each step in the video game will have an influence on the other. Like suppose in a Mario atmosphere, a Mario kind of game, in order to go to the next level, we need to go and reach the destination of the first level. So each level will have the impact. Suppose so many lives are remaining. If we lose one life now, throughout our game, then we have lost one life. That is going to impact the rest of the part of the game. So in sequential setup, one particular step, one particular decision will affect the future outcomes. In an episodic environment, each episode is going to be independent of each other. Coming to the next one, which is cooperative and competitive. I already discussed about this when I discussed single versus multi-agent. So in a multi-agent environment, two agents will exist, two or more than two. That is definitely not single. So there those two agents can cooperate with each other or they can compete with each other. Depending on whether they are cooperating or competing, we will call it as cooperative versus competitive environment. For example, in a competitive environment, chess, a game of chess or car racing, there one player tries to win by competing with the other player, right? So same way, consider another example. This car racing also, each car racer will try to win and reach the destination before the other player. So that is also a competitive environment. Coming to a cooperative one, the robo assembling. So suppose there are some robots, they are all asked to assemble the parts of a car together. There all the robots will try to cooperate with each other and assemble. If one robo keeps and fixes a part, the other robo will try to will try to fix another part in such a way that they are all working together and building the car. It's like Lego games or some puzzle game where 2 or 3, if we are playing together, we'll try to solve the puzzle blocks together, right? That is a cooperative environment. Coming to the next one, which is discrete versus continuous. So here also, if you consider the example, one in which the state and action are finite and discrete, whereas in continuous, if you see, the environment is going to be a continuous one and it is infinite. See here, let us consider the example so that we can understand this concept better. We have competitive environment like chess. There what is happening? It is also an example for a discrete kind of environment. Why? Because in a discrete environment, your action space is a finite one. The chess game will end either with a checkmate or with a draw. It is known, the outcome is known, and it is a finite state space, we call it. So in a discrete environment, we'll have a finite state space. Whereas in a continuous environment, the state and action spaces are continuous and infinite. So the agent must be making decisions continuously with the changing environment. That kind of agent will learn from reinforcement learning. That is, it will learn from feedback and reward method. We will be discussing about reward and punishment later. So the agent will learn from reward or punishment method. Coming to the next one, which is known versus unknown. Suppose the agent has complete knowledge of its environment's rules, state transitions and the reward structure, then it is called a known environment. The agent can perform better in a known environment because it can plan its sequence of actions. Whereas unknown environment means the agent has limited information or absolutely no information about its environment's rules. So the agent will not know what will happen next. See, for example, you have this tic-tac-toe. Okay, this game of chess or tic-tac-toe, that can be considered as known environment because we know how a chessboard will be, and we know that if the horse is able to move 3 steps this way in an L shape, then we can make the other move. Like that, we know the rules of the game. We know how a chess game board looks like. Same way tic-tac-toe also, we know how the game looks like. We know the environment. Coming to the unknown environment, we have some exploration tasks or real world applications where the agent is asked to explore something and find something underwater. There, the environment is totally new to it. Suppose our robo is going to go and rescue some people in a forest. The environment is going to be absolutely new to it. So, those kind of environments will fall under unknown category. So, what are the different task environments which we have seen today? We have seen about full versus partial, that is fully observable environment and partially observable environment. Whether the agent can observe the entire state or only portion of it. Depending on that, we will say it as fully observable and partially observable. Coming to the next one, which is deterministic versus stochastic, the outcome of the action is either certain or uncertain. That is, it will have, if it has randomness in it, the next state, then we will call as stochastic. Coming to the next one, the agent will either be competing or collaborating, that is cooperative or competitive kind of environment. Coming to the next one, single versus multiple. So there only single agent will act or the multi-agent kind of scenario is there. Based on that, we can classify the environment as single versus multi. Coming to static versus dynamic, where the environment is going to be fixed like a crossword puzzle, or is it going to be changing like a car driving? Coming to the next one, which is discrete versus continuous, where it can be finite and well defined or infinite and continuous. So in a continuous environment, we say that the environment is going to keep changing continuously and it has infinite state space. Whereas in a discrete environment, we know the outcomes exactly. You can take the example of a chessboard or a tic-tac-toe game. Coming to the next one, episodic and sequential. The current state, it will not affect the next sequence of actions. Whereas in a sequential environment, the current state will affect the outcome and therefore it will affect the next sequence of actions. And the last one, it depends on known versus unknown. How much the agent has information about the environment in which it needs to achieve its goal. That is what is known versus unknown. If it knows the set of rules and if it knows its environment before, that is a known environment. In an unknown situation where some real life exploration tasks are happening, the environment is not known to the agent. It's going to be new. So that is unknown environment. Now I hope you understood about the properties of task environments in the agent's point of view, what type of environments it can observe, right? So if you like this video, do like it and share it with your friends and subscribe to our channel for regular updates and don't forget to press the bell icon. Thank you.